Hello everyone, welcome to my channel and welcome to another video on integration. I'm still looking at integration of trig functions, and in this one I have two integrals that I would like us to evaluate. The first one is this one here. It's the integral from minus pi to pi of sine 3x sine 2x dx. Now when you have sine 3x sine 2x like that, sine following each other like that, it should remind you of compound angle formula for cosine. So this is page 1 here. The approach to integral number 1 from minus pi to pi of sine 3x sine 2x dx. What I was saying is, if you recall, cosine of capital A minus capital B is equal to cosine of capital A cosine of capital B plus sine of capital A sine of capital B. Now if I change the sign there to plus, I'm going to have cosine of capital A plus capital B. This will be equal to cosine of A cosine of B minus sine of A sine of B. Now, if you look at these two equations here, look at these two terms. I'm looking for the last two terms. Therefore, I have to subtract the two equations. Subtract the second from the first. This left-hand side, you'll agree with me, we have cosine of A minus B minus cosine of A plus B. You'll agree with me, these cancel. And that part, this sign will change that sign to plus sign. So you're going to just have 2 sine A sine B. Now if you look at this part, it agrees with that part there. But I must get rid of 2 because I don't have 2 there. So I'm going to have to divide both sides by 2. So 1 over 2 times cosine of A minus B minus cosine of A plus B. The answer will just be equal to sine A sine B. That means if I put 3x there, I must put 2x there. I must do the same on the left. So this implies 1 over 2 cosine of 3x minus 2x minus cosine of 3x plus 2x. What should this be equal to? It should be equal to sine of 3x sine of 2x, like that. Let's simplify the left hand side. So this is going to be 1 over 2. This is cosine of x minus, I had a here instead of x. Let me change that. It's supposed to be 3x. Remember, where there's a, you put 3x. My hand misbehaved there. We must get rid of that and place it with x. I'll come and fix that, but let's carry on. So this will be minus cosine of 3x plus 2x is 5x. This is equal to sine of 3x sine of 2x. Fantastic. Now this expression is that one there. If you check, is that one there. I must have it replaced by this term on the left hand side. Then I can perform the integration very easily. Taking us to page 2. Maybe I can squeeze that integral in. So we'll say that integral then changes to the integral from minus pi to pi of 1 over 2, open brackets, cosine of x minus cosine of 5x, like that, dx. Look at how easy that one is now. Instead of having these two terms here, that expression very difficult to deal with, but this one is much easier. Now let me fix this up. We need to have 3x there, like that. Fantastic. Now let's carry on with the evaluation of this integral. I'm going to take it to the next page, page 2. All I have to do now is to distribute the integral and the half and the dx, taking us to page 2. If you agree with me, what I said is that integral is the same as, watch this, 1 over 2 integral from minus pi to pi of cosine of x dx minus 1 over 2 integral from minus pi to pi of cosine of 5x dx, like that. Nice. So let's work on the left hand side here. 1 over 2 integral of cosine is just sine, so we have sine of x evaluating from minus pi to pi minus 1 over 2, and the integral of cosine is sine, but we have 5x, so it has to be sine 5x over 5. Remember, you can verify that by using use substitution. We're evaluating this from minus pi to pi, like that. What do I do? Take the 5 out. Remember, it's 1 over 5. This becomes 1 over 10. So this part here is 1 over 2 times sine of pi minus sine of minus pi minus 1 over 10. Like I said, this must be closed. That bracket, we must close it. 1 over 10. And then here we're going to say the inner part is going to be sine of 5 pi minus sine of minus 5 pi, like that. Now you should recall that sine of n pi, 5 pi, and so on, 3 pi, 2 pi, the answer is 0. So, so what do we have now? Because sine of pi is equivalent 180 degrees. Sine of 180 degrees is actually 0, or any multiple of 180 you get. Say sine of 180 times 2, 360, it will be 0, and so on. So this is 0, and that is 0 also. And that is 0 also, and that is 0. So basically what we have is 1 over 2. And here, remember, if you want, you can take the minus out. This is going to be sine of pi plus sine of pi, because sine is an odd function. The minus comes out, multiplies with that, change to that. Minus, it doesn't change anything, by the way, 1 over 10. And then this is going to be sine of 5 pi plus sine of 5 pi, like that. So this is 1 over 2 times 2 sine of pi. Here it's going to be minus 1 over 10 times 2 sine of 5 pi. So this is just sine pi, and then here it will be, of course, the 2's cancel here, these cancel, and that part will be minus 1 over 5 times sine of 5 pi. So this is basically 0 minus 1 over 5 times 0. Our final solution is actually 0. Verify these answers, go through these integrals, and then check the solutions and see if you're getting the same solutions as these solutions that I'm getting. All right, that was first integral. Let's look at the second one very quickly. The second one is an indefinite one. Here it is. Still, we are busy with trig functions. We are now dealing with the integral. We're to integrate cos 6x cos 4x dx. Now, like I said, whenever you have numbers there, don't try to rewrite those into simpler and smaller numbers. Think about compound angle formula. So, taking us to, this should be our page 3, if I'm not mistaken. That should be page 3. Yeah. So this is page 3. And the integral I have, second integral, is the integral of cosine of 6x cosine of 4x dx. Now, when you see cosine, you know that we have to use cosine of, let's say I'm using capital A, and I can keep the minus, the plus, it doesn't really matter. So let's have the minus first. Cosine of capital A minus capital B. This is going to be equal to cosine of capital A cosine of capital B. And then you have plus sine of A sine of B. The second one, we change the sign there. Cosine of A plus B This is going to be equal to cosine of A, cosine of B, minus sine of A, sine of B. Now, if you look at these two terms, is cos, cos, I need this part there, which means these two terms, I don't need them. So I can simply add these equations up. I'm adding them up. This plus that, it's going to be cos of capital A minus B plus cos of A plus B. You'll agree with me, these two terms cancel, and these two terms added together, it's just 2 cos A cos B. If you look at this part here, I don't have 2 there as a coefficient. I must divide by 2 both sides. So what does it do we get? We get 1 over 2 multiplied by cosine of A minus B plus cosine of A plus B. This will be equal to cosine of A cosine of B. Fantastic. Now, if you look at this is 6x, 4x. I must put 6x, 4x there. I must do the same on the left. So this implies 1 over 2. And we're saying cosine of 6x minus 4x. And then plus, 6x minus 4x plus cosine of 6x plus 4x. What should this be equal to? It should be equal to cosine of 6x and then cosine of 4x, like that. This is what we have there. And simplifying the left hand side, I'm not happy with that x, but it doesn't matter. So moving forward, we have 1 over 2 will be equal to, simplify this part, it will be cosine of 6 minus 4 is 2x, 6x minus 4x is 2x, plus cosine of 10x. This expression is exactly equal to cosine of 6x cosine of 4x. So this one here can be replaced by this expression here. That integral therefore changes to the integral of 1 over 2 open brackets cosine of, what do we have here? We have 2x plus cosine of 10x, and then what do we have? We have dx, like that. Fantastic. Now let's distribute the half, the integral and the dx. Remember, this expression has been replaced by that because you can see it here. This term expression equals that expression there. So now moving on to the next page, page 4, quickly to finish this up, we are basically saying now, let me finish this up quickly. It's half the integral of cos of 2x dx plus half the integral of cos of 10x dx. Right. Working on this part here, you'll agree with me, integral of cosine is just sine. So this is half times sine of 2x, but there's a 2 here, so we have to divide by 2. Plus, this is x, plus half the integral of 10 cosine of 10x. Remember, it's sine of 10x. We must divide by 10 because there's a 10 there. And then I have to say plus a constant c. Simplifying this is just a quarter of sine of 2x plus 1/20th sine of 10x plus c. This is the final solution to our second integral. Not so happy with this 2 here, but yeah, you can see it. Our second integral was this one. There it is. And we evaluated it so easily by using the compound angle formula there. Right, I'm going to stop here in this video. I'll see you in the next one.